Good morning, Professor and my classmates. Today, I'm going to present my final presentation on recurrent neural networks for sequence data. So, the topic that I have chosen for my final, as per the requirement of the final project, that is a time series data set, a simple neural network with sine wave data, LSTM neural network, um, recurrent neural network, LSTM with time series data, redesign the neural network and compare the network performance. So if I move on to the next slide, that is part one, time series and data set. So here I have chosen a data set that is US historical stock prices with earnings data. So here it has 20 years of historical US stock prices from MX, Nasdaq, and YSE markets, consisting of 4 files, that is dataset summary, um, earnings latest, stock price, and dividends latest. So that dataset includes daily stock price, earnings data with open, close, low, high, trading volumes, adjusted closing price, and stock split coefficient, as well as data that has been used for each stock, such as earnings date, estimated EPS, and reported EPS. And it has around 7,000 plus stocks. The dataset is updated in batches from multiple sources, and that may take up to 2 weeks for individual stocks to catch up. And the source of data for this dataset include Nasdaq, Yahoo Finance, JAX, and Alpha Bandage, and May Up Alpha Vantage. So additionally, each table in the stock price and earnings files contains information on the total number of daily stock prices and the time frame of the stock prices of prices, and the total number of earnings, and the time frame for earnings for that particular stock. And here I have also given the link of the dataset that has been downloaded from kaggle.com. And now if I move on to the next part, that is part two, simple recurrent neural network with sine wave data. So here the simple recurrent neural network is a single layer neural network with feedback that consists of only one hidden vector, that is age. The simple recurrent neural network and feed-forward neural network, which includes a fully connected layer, make up the architecture of the RNN with the simple RNN cell. Here we have used dense sample RNN layer, the dense sample RNN layer that is used as fully connected layer to build, train, and test the simple network, recurrent neural network. And we have used a time series generator as well to generate sine waves and to feed into the model. So here we have used the Keras library, which is a powerful tool for constructing, testing, and training the model. And we have used min-max scalar that also utilized to generate sine waves and pre-processes the data. So, and the data is loaded into the data frame with X and Y values, where X represents the index and Y represents the actual data. So X represents the index, Y represents actual data. The recurrent neural network is trained using the fit generator method and evaluated on the test data. And the last point is predicted values are stored in a list called prediction, and a new data frame is created with two columns. The first column represents the sine wave and the second column represents the prediction. Now, if I go to the file where I use the code to generate the neural network, that is simple RNN with sine wave data. So here I have included all Python libraries, that is Panda, NumPy, Matplot library as well, and I have imported the Keras time generator and min-max scalar. So here I have generated simple sine wave using NumPy, x and y axis. This is the plot that we have taken, and here the data has been loaded into the data frame, the x and y, and for the train and test purposes, we have encountered 20% data for testing, and here we and the length, test length is 154, and so if I go to not to normalize the data, we have used min-max scalar and time series generator, where we have used length 50 and base size 1, and to build, train, and test the model. Here the features, to check how many features we have used in the training model. So we have used one feature, and we have we have added two layers into the simple recurrent neural network and dense layer. So two layers, that is, one is recurrent neural network, another is the dense layer. So so to compile the model and use the optimizer, Adam and Loss MSC, here we use MSC, because the data is continuous. So the model is sequential, and to feed the model by using the command that we have used, epoch here 5, only. So that's why the epoch has been generated, 5 epoch has been generated. And if here to visualize the data, load the loss data into a data frame and visualize the data frame. So this is the visualization of the data frame. And if we evaluate the data here, the length is 50, and the length is 50, and this is the evaluation. So and this is the visualization of the data that has been updated, and the original sine wave that we have got finally. So this is the original sine wave. Okay, and so if I go back to the next part, that is part 3, recurrent neural network LSTM neural network. LSTM neural network, that is the vanishing gradient problem is a common issue in deep learning networks. That is including, it could be RNN as well. In RNN, simple neural network, the gradients can become too small and making it difficult to learn long-term dependencies, leading it to slower training and an inability to learn long-term dependencies. And the vanishing gradient problem can be especially pronounced in recurrent neural network with certain types of activation function, such as sigmoid function, and the ReLU function is also an alternative to mitigate vanishing gradient in deep learning networks, and exploding gradient occurs when gradient becomes too large. Then here gradient clipping and weight regularization are techniques used to address the exploding gradient problem in deep learning neural networks, and the simple RNN that struggles to capture long-term dependencies in sequential data, making it unsuitable for some tasks. But the simple RNN can become unstable when dealing with simple RNN can become unstable when dealing with the longer sequences, leading it to slower learning and more difficult to optimize for the optimization. So the long short-term memory and the graded recurrent unit networks are more advanced types of recurrent neural networks that address simple recurrent neural networks limitations. And long short-term neural networks, that is use a more complex memory and getting functions to selectively remember and forget information over the time, allowing them to capture long-term dependencies more effectively and prevent the vanishing gradient problem. Now, if I go back to part 4, that is recurrent neural network, LSTM, long short-term memory with time series data. That is, so to work with time series data, we will use a special RNN that is called dropout, which includes a fully connected layer. So here, a dropout RNN architecture with a fully connected layer is being used for time series data analysis. We will use libraries from Keras libraries, and that we'll use a time series generator and min-max scaler that also be used into sequence and data normalization. So for data input sequence and data normalization, we'll be using time series generator and min-max scaler that comes from the Keras libraries, and comes from the Keras library. And the dataset that we have used, it has 3020 rows and 7 columns of stock data with multiple data points. So we will perform time series analysis on the data focusing on a specific time series with an index of 4. And the dataset is split with 20% of the data used for 20 is for testing. So we will be using 20% data for testing. Then the data is normalized using min-max. So min-max scalar function will be used for normalization of the data, and time series generator is created with a base size of 32. The neural network architecture will also use an LSTM layer followed by a simple recurrent neural network layer with a dropout. And the model is being used 100 epoch here in this model using the fit function with 37 batches of input sequence. So to achieve the higher accuracy, and to improve the dataset is split into training and testing sets. 10% of the data is used for testing, and the architecture includes 2 layers, that is LSTM. One is LSTM and other is the dropout layers. So dropout layers, here the dropout layers I'm going to use 20%. So 20% of the for the dropout layers. And we will also perform the prediction belows back to their scalar, original scalar for better analysis, and the LSTM architecture that consists of 4 layers that interact to produce the cell's output and state. So if I go to the next slide, that is showing the overall parameters that has been used for recurrent neural network, a long short-term LSTM with time series data. So here we have used a stock price data, and for testing purposes, 10% has been considered for testing purposes that I have discussed over here. 10%. Here 10% of the data is used for testing, and 20% of the data is for dropout. So and we are using 2 layers. That is one is LSTM layer, another is the dropout layer. And here the length of time series input sequence, that is 60, base size for training 32, base size for testing 1. And here we have used number of epochs, that is 100. So now if I go back to the code, Python code that we have used here. So here, if I see from the beginning, so here we have import pandas, numpy, matplot library, as well as we have import sequential LSTM dropout dance for time series recurrent neural network. And we have also used time series generator min-max scalar function. So the dataset that we have downloaded, it's the range of time, I mean the time period, that is 2006 to 2018. And here it has 3020 rows and 7 attributes, the variables. So the summary statistics of this dataset, the table, it has open, high, low, close volume, and if I this is the plot size that the it's a closing price closing price that has been generated by the plot, and it has the length of 60, and this length is the total observations that we have in our data set. And for testing purposes, as I discussed, we have used 10%. So the 10%, that is so 302 out of 3020. So that is 10%. And if we split the data set into for training and testing purposes, so the testing length would be 302, and the split index would be 2718. So if I normalize the data, we have used min-max scalar to normalize the data, and time series generator functions for training the data. So to build, train, and test model, we have used a ReLU activation function, and we have used 50 units for LSTM. And so if I visualize the model's performance after training, this is the visualization of the model after training, and it was the testing, the after training, the visualization of the data is so predictions. And so here we have used 40 epoch to for the feed generation, to build, compile, and for forecasting as well. And so after forecasting, okay, so and now if I go back to the presentation, the next part would be redesign. So if we redesign the network by changing the parameters, so this is the LSTM with time series data that we have used some parameters. The data set is same, but if I redesign, so here if I go back to the again, so here this is the close line and this is the forecast line. So if I compare the performance with changing some parameter in between these two recurrent neural network with time series data, by changing some parameters, this is the redesign. So so we need to redesign the neural network. That is the dropout, the project, it involves time series data analysis using recurrent neural network with dropout and MLP. So the library, the function that we have used here also, the time series generator and min-max scalar from Keras library that are imported for data processing. And here also the data set has 3020 rows and 7 columns with a summary of the numeric attributes available. That so the data is split into accordingly is training and testing sets using ILOC and normalized using min-max scalar to improve the performance. And to improve the performance. And if I go to the next slide, so here a time series generator is created to generate input sequence and patches for model training. So the neural network architecture uses the LSTM layer followed by the simple neural network layer with dropout that has been using from the sequential keras. So here we are going to use the 70 epoch and 40 batches of input sequence. So this is the main difference, that we are going to change the epoch size and the batch size. And the model is tested using the last 50 data points as the test data, and the normalized with the batch size of 1. So the LSTM model consists of 4 layers with 50 neurons for the LSTM layer and 2 hidden layers of 32 neurons each. 6 fully connected layers with a dropout rate of 20%. So this is the summary of the redesigned neural network that has been considered. The changes is basically number of epoch and the batch size. We are going to use the same 2 layers here, also the dropout layer and LSTM layers. And for testing purposes, we are going to use 20%, where in the previous we have used 10%. So, and the model, we are going to use the keras sequential model. Now, if I go to the Python file, that is redesign the neural network. Again, we have imported these files in pandas, numpy, and we have used sequential dropout, dense. We have imported the time series generator, mix, min max, time series generator, and min max scholar. Here also we have use the same data set that has a range from 2006 to 2018. And this is also the same rows and 7 attributes. And so here mainly we have changed the epoch size, where this is 70 has been used for this epoch. And so this is the visualization model's performance after training, and predictions compare close series, build train. So here it is for forecasting. It is the epoch size is 20 in feed generation. So this is the basically changes that we have been made here in the file, that we have used 70 epoch and 40 batch size. Now, if I go to the compare of these 2 models that we have used by changing some parameters, then we can see the this compares LSTM and RNN in terms of data set size and quantitative evaluation. The LSTM outperforms recurrent neural network in terms of training time and performance on the same data set. The test a test data set is used to simulate a real data world scenario of stock market observations obtained every year to forecast the following month. And the data is fitted using online training with a batch size of 1. The percentage of dropout is increased from 10% to 20%. the test percentage is increased 10 to 20%, and the dropout percentage is increased 10 to 20% as well. And the model performance is evaluated quantitatively, and the results show slight changes without any significant change in performance observed. So that's the basic changes that have been made by redesigning the recurrent neural network, and the performance is evaluated quantitatively. And thanks for listening to me. Thank you all.